welcome to lecture number 32 of GE 103. So in this lecture, I will quickly explain the concept of data structures. And as I have mentioned you already that this week is the last week. So if I'm uploading a lecture today, if possible tomorrow I'll upload another lecture, and then I will will stop uploading new lectures because this it is already NSEM is already near. So I hope all these concepts are all means that I have already uploaded all these videos you have already watched, and it is clear to you. So in data structure, actually it's a different subject, and if you see in computer science, the CSE people students will read this course data structure as a separate course, not it's a part of programming language. But since we have to discuss it here, so what happened this time, because of this online mode of teaching, I was also a little bit slow. Otherwise, what we normally target is that after mid-sem, within mid-sem, or maybe just after few means 1 week after mid-sem, we try to finish the concept of C programming, and then we start data structures. But that is not possible here because I don't want to go fast in online mode. So that's why I spend a lot of time on C programming, and so that you should understand the concept of C programming. And now I'm just touching the basic concept of data structure, and the rest you have to, if you are interested, you can study by yourself. And if you are from CSE, or I think from math and computing, I think you will have a separate data structure course also for you. Okay, so the first question that here need to be discussed is, what is data structure? What is the difference between data structure and other variables and all that we have studied in programming language? Okay, the data structure is what you can say, sorry, yeah, these are some specific structures or specific or what you can say data items that we use in programming language to make our life easier. So why we learn programming language? To do some real life solve some real life problems, right? Every time we don't just understand learn a programming language to solve assignments. It is we're learning a programming language to resolve a real life problem, to develop a complicated software and all. So in those cases, just understanding array of structures, this will be not enough. If you remember when I was explaining structure, what I said, that if you want to represent a table like data, then array of structure, you have to go for array of structure. So in that case, if you remember that if you have a array of table like data, then which data structure you want to use? Array of structure, that is also a data structure. Okay, so there are many such requirements when the array is not enough. We have to go for something else. Why? Let me explain here. Suppose this is an array. The first line here is an array. Okay, so in this array, suppose this is a this is not just a small array. You can assume that there are thousands of lines in this array. So what is the advantage of array? There is advantage and disadvantage both in array. In array, if there are thousands of lines, if you want to access a particular element, you can just simply access that writing array name. And for example, if this a suppose you have a array integer a of 2000, and if you want to access the element number 1000, then you can simply write a 1000, right? So in this way you can directly access that element. So accessing element is easy in linked list in array, but the problem in array is, suppose if I want to delete this particular element from array. So you know the properties of array, right? Every element must be in contiguous memory location. So if you just want to delete this particular element, then what you need to do, you have to shift all this data one by one position to the left, right? That is a difficult task, because this is a very time consuming task. Assume that it has 2000 or 2 lakhs entries here, and you want to delete a element here, then you have to move all the data to the left side, every element one position left. It's a difficult job. One more thing is, suppose if you have a sorted array, and you want to insert something here. So if you want to insert a node, so suppose it is sorted array and you want to insert 20. So if you want a 20, then 20, assume that 20 should be inserted here, otherwise it will not be sorted. So if you want to insert a data here in array, one, there is no place here. Now what you need to do, you need to shift all the data here to the one position right to make a gap here, and in this gap you have to put 20. So it's a very time consuming thing. Assume that you have a student record, suppose 2000 instead of 2000. If I say it's, there are 2 lakhs student records available in a table. So and it's designed as a array. So if you want to insert something in the position of a, suppose a 40, then what you need to do, you have to right shift everything one position, so that there should be a gap made at a 40, so that a new data can be entered there. So that is a very time consuming thing. And so these are the disadvantages of arrays. So what you can do, okay, so this is the last ungraded assignment I'm giving you, that you have to go to the internet and try to understand the concept of advantage and disadvantage of array. Advantage and disadvantage of array as compared to linked list. You search it in the internet, you will get the advantage and disadvantage. You read it. This will be important for your exam. So now let me explain you the concept of linked list. Uh, so instead of an array, suppose we have all these values here. Suppose different variable. This is a variable. This is a separate variable. Why I have written like this? Because if I remember, I have explained you that once you declare a variable, a memory will be assigned in the computer memory like this for that variable. So assume there are different variables are there, and this A, B, and all these are. You can consider that these are the address. Instead of writing numeric address, I have given a b c like this. Okay, let me complete it. A b c, and then d, let me consider d this, and then sorry, this is d, this is e, this is f, this is f. Okay, so what I need to do here, these are the variables, independent variables, suppose. So now I want to connect them. So how can you connect them? If you are at A, you have no idea where E is, because there is no connection between A and E. There is no connection between A and B. Okay. So but here, suppose instead in A, if suppose A is for integer, so there is a integer variable stored here, fine. But with this, if somehow we can also store the address of this variable B. Suppose this is the scenario. If we can store this, then what does that mean? From A, can we go to B? Yes, because what we are doing in A, in this address, always remember A, B, C. I'm saying these are the addresses of this variable of this location. So in this location, actually 20 is stored. And with this 20, there is another part. So there are two parts here. Another part I have stored the address of another node. Which address? Address of B. What does that mean? It means that since I have stored the address of B here, so a connection has been established like this. Like, why this connection? Because since the address of B is stored here, so from here you can go here, because you just follow this address. If you know a address, you can directly go there. The same thing we are doing in array also, right? How we are accessing A40 directly? If you want to access A40, that means we know the address, because it's an array. So if the base address is X, then A40 will be X plus 40 into 4. So we know the address. So that's why if we know the address, you can directly access it. So exactly we are doing the same thing here. We're storing the address here. If we store the address here, then we can directly go here. But in this case, suppose here in B, 30 is stored. Okay. But if you are in B, can we go to A? No, you cannot go, because in B you have no clue. The address of A is not stored, and you have to remember that these all these a variable, they cannot see each other, because these are the independent memory location. Unless you point them like this, they cannot point, means see each other. So now in B, if I write C, then what does this mean? Means from B you can reach C. So there will be a connection like this from B to C, right? And in C, suppose the value store is suppose 40, and D is written here. So if D is written here, then there will be a connection established like from here to here. right? And from D, suppose 55 is stored and connection is for E, and there is a connection for E, then there will be a connection from here to here, okay? And it is for 99, and it is, let me write F here. So if there is a F here, so there will be connection from here to here. And let me store here um 55 uh, 550, and let me write here null. Okay, let me expand it a little bit. Let me write here null. Null means it is not pointing any other elements. Okay, now if you see this, now if you are in A, suppose if you are in address A, can you reach address F? You cannot directly, but if you follow the chain, you can. First of all, if you are in A, you can see there is a address written here. Address is called B, so you'll read B. When you'll read B, you will see there is a address written called C, so you will read C. So when you'll read C, you will see there is a address written here called D, so you'll read D. When you'll read D, you can see there is a address written here is called E, so you'll follow this and you'll read the memory address E. So you'll go here, this is the memory address E. So in memory address E, you will read the data as well as you'll also read an address which is called F. And if you read that memory of that address, then you will be here. And so ultimately from A, you can also reach F. So these are connected. That's why this is called linked list. Why it is linked list? Because all these variables are connected, and each of these variable is called a node. It's not just a variable, it's a node. Why it's not just a variable? Because there is no single data, or you can also consider it as a structure. Why it's a structure? Because you can store any number of variables here, means any type of data. It's not just integer, you can store any integer plus integer, name, age, anything. So you can say it's a structure, means you can store a structure of variable information here. But what, for making simple, what I said, it's a simple value 20, and a value and an address. These two things are stored here, so it's not a single variable. That's why we, in terms of linked list, or you can say in terms of data structure, we call this as a node. Okay, this is a node. So if this is a node, and if we maintain this type of connections, so from B there is a connection, from A there is a connection with B, from B there is a connection with C. But always remember, this arrow are given here only for your understanding, but actually this arrow is not required, right? Or this arrow is only for your understanding. There will be no this kind of physical connection in computer. Why? Because connection will be established the moment you write B here. The moment you write B here, then when you will read this memory location, then you will read that data. Data is actually 20, and with this data you are also reading an address, or you can say it's a pointer, right? It's a pointer. Pointer means, pointer is a variable which can store the address of another other thing, right? So here there is a pointer. So if you read this pointer, you will read the address of another node. Which node? This node. So in this way there is a connection. That connection I am showing you as an array here. But don't think that this array is a physical link in this computer. So why I'm saying all these things? So at the beginning people have many kind of doubts. That's why I'm clearing it. So connection, establishing connection means I'm storing the pointer of another node here. Okay. So now what is the advantage of linked list? First of all, we will say what is the disadvantage of linked list as compared to array. Is, as I have said, if you have an array of 20,000, 2 lakhs, and if you want to access array A 4,000, you can directly access it. Why? Because you know the memory address of 40, or suppose 40th element. So you know the memory address of 40th element. How? If the base address is A, then you will write A plus 40 into 4. Then you know the memory address, will directly access it. But here, in linked list, if you want to access the fourth element, you don't know the memory address of fourth element directly. You suppose what happened normally, this is called head node. In linked list, this is called head node. We can write it here also. This is actually a, there will be a head pointer, and head pointer always points this. There will be head pointer. This is a pointer variable, and head pointer every time it's points the first node. So if you only know the head pointer at the beginning, and if someone says that read the content of fourth node, you cannot directly access it because this memory location are not contiguous. What happened in array, the memory location are contiguous. So it means that if the base address is this, so if you want to calculate the fourth one, you can apply a mathematical formula so that you can access this fourth element, right? Because the memory is contiguous. There is nothing in middle. But here you can see their memory is not contiguous. One is stored here, another is stored here, another is stored in some different memory location. So they have just a connection with each other, but they are not contiguous. So if someone says that access the fifth element, you cannot access directly. Yes, you can access, it will take time. How? From head, you'll start from here. Okay, this is the first element, then follow this link, will go here. This is the second element, follow this link, will go here. This is the third element, follow this link, will go here. This is the fourth element, and follow this link, will go here. This is the fifth element. So you'll print 99. So in this case, means if you want to access something in linked list, then you have to traverse it. So here we say that the access time is time complexity is order of n, because if you want to access something, you have to traverse it. But there are some advantages of linked list also as compared to array. The first advantage is, suppose if you want to delete this node. If I want to delete this node, then what is happening in array? If I want to delete this node, as I said, we have to shift all the elements in the right side one position left to remove this gap. Otherwise, if you just remove an element from this array, then a gap will be created. So you have to shift everything. So that is the order of n complexity in array. You have to shift everything one position left, but that is not required here. Suppose you want to delete this node. Okay, if you want to delete those, if you know the previous element, suppose if you know this element, this previous element, then what you can do here, if you want to delete this node, then first of all you say that instead of writing c here, what you'll do, that you will write here the address of d. So because suppose you want to delete this node c, what will do, you have to find out the previous node of c. So suppose this is the previous node of c. So what is the next node of c? Next node of C is D. So here you will write next node of C is D, and the moment you write this, so this establishment is broken, right? This link is broken. So instead of this link, a new link has been created. Which link? This link has been created, right? This link has been created. So now you can simply delete this node. If you simply delete this node, then that is done. So in linked list deletion, that's why deletion is simple as compared to array. So let me um, uh, so I have just I want to keep this linked list here for some time to explain you some other concept. Okay, so now, and if you want to insert something here, suppose you have another node here 40, suppose you have another node here, and this is actually, suppose it is storing 33, and nothing is written here. Actually initially it is null, suppose. Okay, you want to insert it between d and b and c. Oh, it was previously, it should be c, huh? You want to insert it between b and c. How you can insert it? If you remember, I have said in array you have to right shift everything, every element, to make a gap here. There is no such requirement here because this memory are not contiguous. So what you will do here, suppose, so you will write, suppose the address of this element is also important. So suppose the address here is b1. Address here is b1. So what we will do here, instead of c, I will write here b1. Okay, the moment you write here, this link has been broken, and there is a established connection will be established like this, right? Let me write it here, maybe it's not clear. Delete it. The connection will be established like this, and then here in b1 write c. If you write this, then there will be a connection will be established from here to here, right? Done. So you can insert it uh, without shifting all the elements to the right or left. So it means that in linked list, insertion and deletion are easy compared to array. So if you want to do some operation your requirement is that you have to do something where you have lots of data, and sometimes you have to insert at the beginning, sometimes you have to insert at any position. Insertion and deletion is very important for you. Then you should go for linked list instead of array. But linked list is just the initial data structure. Many times we don't use linked list, but there are many other efficient data structure which is way better than both array and linked list that we use. But this is the entry level data structure. That's why I'm explaining it here. If you understand the concept of data linked list, you will understand the concept of other language, other data structures also. So now let me explain something more here. Actually, what we normally do in data structure course is not just about the programming, or you can say programming is secondary in data structure. If you know the concept of programming, then it is very easy to understand data structure. Yes, sorry, that is easy to implement data structure, but if you cannot find the logic, you cannot implement it even if you know the programming language. So actually there is a programming language and concept of data structure are not exactly same. You have to understand the programming concept of any programming language, otherwise you cannot implement the logic of data structure. But the logic of data structure is independent from any programming language. It is a separate part. That's why data structure is a separate subject in computer science. And many times when a data structure course is taught in class, you can see that professors don't write explicitly the programming. They write some steps. This is called algorithm, or we can say pseudocode. That is actually the logic. So what you can say in a simple word, that when a data structure teacher explain you link all the data structures, how to insert, how to delete, and all these things, they try to explain you in terms of what you can say logic, not exact programming. They will the way that I have explained now, they will say this particular thing in terms of some particular rules which is called pseudocode or algorithm and all. And just to explain you the logic, because once you know the logic, it is your duty to implement it in a programming language, and for that you need the knowledge of programming language. Yes, if you want to implement the knowledge, the logic of data structure in any programming language, especially in C, you must have an expert in C. Otherwise you will get lot of error in C. So that's why first you have to clear all the basics of C. And also the use of pointer is very important in data structure. If you want to implement any data structure in C, you have to manage many pointers. And also understanding the concept of pointers is very important here. Pointer and structures, these two are very important thing. Okay, so what we normally do here, suppose if we have a node, this each of these is a node, right? So node has a two part, I said. Normally node has two part. One is, suppose I'll say value, and another is next is a pointer. Okay, every node has a two part, I'm saying. So as I have said at the beginning, this is not just a value. You can store any value here. This can be any variable, any structure variable, anything. And the last is a next, it's a pointer. Which pointer it is? It's a pointer which store the address of any other node of similar node, right? It's all of these are similar nodes, so it will store the pointer of another node. So assume that each of this node has this structure, value and next. So now as I said, this one that I have explained here, how I have inserted p1 here. Suppose you have two node here, b is here, c is here. Okay, these are the nodes, and you want to insert b1 in between b and c. Then what I have said, how to do it? First you have to do is, as I said, what I've done, I have written b1 here. If I want to write b1 here, what I will do, b dot b next equal to b1. I'll write this. Let me explain you step by step. Let me delete all this thing and let me connect this. This is our old linked list, right? This is old linked list, and I want to add b1 in between. So if I write b next equal to b1, as I've shown previously, so what will happen if I write b next? So previously it was written c, right? It should be c here, but the moment you write b next equal to b1, what will happen? If you read convert this c to b1, suppose I have already changed this to b1. So if you write b1, what will happen? This link will be deleted, right? This link will be deleted, and a new link has been established between this and this. That is fine. You have established a link, this and this. Now what I said, that here you will write c. Initially it is null. Here you have to write c, but how you will know the c? How you will know the memory address of next node? Because it is gone. See, that's why it is important. So some logic is very important. So if you write b next equal to b1, then what will happen? There will be a connection between b and b1 has been established, fine, but the connection between b and c is gone now. So the complete part c, d, e, and f, these part is became invisible from this part, because there was a connection and you lost this connection. So when you are doing some operation in data structure, you have to very careful that what you are doing. So if you write this line b next equal to b1, then this link will be established, but the connection with the remaining part of the linked list will be deleted, and so you cannot get it, because there was only this connection through which you everything was connected, and you destroyed this connection. So how to establish the connection? To do this, you can't follow this particular operation. What you have to do, this is your original data structure, right? This is c, this is your original linked list. What you want to do first, before this line you have to write another line. Here you will write that b1, you know you want to insert b1, right? So b1 next you will write equal to c. If you write b1 next equal to c, it means what? Here you are writing c, here you are writing C. The moment you write C here, there will be a connection established between these two, right? If you write B1 next equal to C, it means in B1 you are writing C. In B1, if you are writing C, then there will be a connection between C to B1 to C is created. That is fine. Now you write this line B next equal to B1. If you write B next equal to B1, what will happen? Here you are writing B1. If you write B1, this link will be deleted and the new link will be established between these two. Understood? So now the link has not been broken and now a new node has been inserted in the linked list. So that's why the logic is important here. Programming is secondary here. You have to understand that this should be first and this should be second. If you just reverse these two lines, swap these two lines, that if you want to write b next equal to b1 first and b1 next equal to c at the last, then you destroy the complete logic of inserting a node, and in fact you will destroy the remaining part of the data structure also. So that's why logic is important in data structure. So suppose if you want to delete b1 now, then what you will do? If you want to delete b1, then actually what should happen, that this b now point this c, right? If you want to delete b1, this b now point c, then how you can, suppose at the beginning what I said, that you only know, let me, actually data structure is a subject which is better to teach in blackboard. This type of teaching is very difficult for data structure. Okay, so now at the beginning you only know the head pointer. Head, there is a pointer called head, it is pointing this node a, this node is pointing by head pointer, right? So now if you want to delete b1, sorry b1, what you need to do, you need to find this node. So what you will do, we have to search from here, from head pointer we will go here, we'll check, and then from here we'll go here, and from here we'll go b1. But assume, at these things we'll not discuss now, assume that if you want to delete b1, then we assume that we know the pointer, both address b and b1 we know. So suppose b and b1, both these address are known to us now, somehow that we have searched it, or suppose these two pointers are known to us. Why I'm saying pointer? Because pointer store this address of this. So b, b1, all this is a store, these are pointers. So we have two pointer b and b1. Okay, and so now if we want to delete b1, how can we delete it? We can simply write b next equal to c. If we write b next equal to c, then what will happen? Here I will write c. The moment I'll write c here, then this link has been deleted and this link will be established, right? I'm doing this, but I have not deleted b1 yet. B1 is not deleted yet, b1 is still there, so the shape of the linked list should be like this. So now the next line should be delete. So what will do, suppose, let me write delete b1. So if you write delete b1, then b1 will be deleted from here. The moment you will write delete v1, then this connection will, everything will be deleted, and this is the new linked list. So you should understand the process of insertion and deletion in linked list. So both for insertion and deletion, what is important, you should know the pointers. For insertion also, you should know the pointer b after which you want to insert. And if you for removing a node, you should know the previous node. For example, there was b1 here and you are trying to delete b1, so you should know the pointer b. That means the previous pointer is very important when you are deleting a node from linked list. And we are inserting it, then you have to understand that after which node you are inserting, that is very important. So if you insert something here before this a, then the new element will become head will change, right? So every time remember, the first element is considered as a head, and I can say head is the pointer which always point the first node of this linked list, and the last node is not pointing anything, that's why last node pointer is null. So if you want to traverse this list, what we do, traverse means if you want to print everything, so what we can do, we will start with head, right? So what we will do, there will be a pointer like p1 equal to head. So head always point the first element, so while p not equal to null, okay, then we'll what we'll do here, we'll write print, it should be printed, but I'm writing print p value. As I said, every node has two things, every node has two parts, right? Value and next. So initially which node I am, initially I am saying, sorry, it's not p1, it's p. Suppose there is a pointer p which is same as head. So initially which node the p is pointing, p has address of this node, p is actually a at the beginning. So what it is doing, p is null, no, p is not null, p is actually equal to a. So it is printing the value of this p, so it is printing 20. After printing 20, what it will do, it will write p equal to p next. If it is right, p equal to p next, what is the value of next, p next? So here you can see a, currently p is in a, so what is the value of a next? A next is b, so now p will become b. P, the moment p will become b, we are here, right? We are here, and again while loop will start. P is null, no, p is b, so print b value means it will print 30, and then it is saying p equal to p next. So now p next is from here, b next is c, so now the value of p will be c. So in this way we will continue, we will print everything. After e we will be here in f, and from f when you will write p equal to p next, then the next value stored in f is null, so p will be null. So while again it will come here, and while it will say p not equal to null, yes, p is null, so it will come out from this loop. So in this way you can traverse the complete linked list. Okay, so as I said, I'll only cover the basics of linked list. So in next class, what I'll do, I'll try to implement this concept in a C programming language, and that will be the last class. And one more thing here, a simple modification of linked list is possible. There are three modification possible. One is called circular linked list. Circular linked list means if I connect this like this, then it's a circular linked list. Why circular? Because from any node you can reach any other node, right? Because there is a circular dependencies here. This is called circular linked list. So in this case, to maintain circular linked list, what you need to write here, I'll write a, because if I moment I write a here, there will be a connection established between these two, right? So this is called circular linked list, and this is called single linked list or singly linked list. Okay, because there is no circular dependency. Another linked list is called double linked list. Double linked list means for every node, this is the next connection, there will be another pointer stored here. First there will be another pointer stored here called a. So a means from this node b, either you can go this direction and you can find c, either you can go this direction and you can find a. So it means that there is a reverse connection also there. There is a reverse connection also there. That is called doubly linked list. And in this case here it will be null. First one is null because it is not pointing anything to its right. Okay, and here I'll also store b, and if I store b, then this will point back direction like this. And the same thing is here also. If it is doubly linked list, then connection will be from both sides like this. Okay, and 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 the last one is also like this. Okay, and here again, in from F, there will be previous connection is, suppose this is the previous connection, the previous connection is E. Sorry, actually, ish, let me write it here so it will be easy for you to understand, or let me delete it, otherwise maybe it will confuse you. Okay, so and here its backward pointer is D and its forward pointer is null. Okay, this is called doubly linked list. Why doubly linked list? Because from every node you are pointing its previous node and the next node. So if you want to implement in node in programming, that there every node has three things: value is there, and previous and next. There are two pointers stored in each node. This is called doubly linked list. So inserting and deleting in doubly linked list is little bit complicated than single linked list. I'm not explaining it here, otherwise it will be very complicated because I have not discussed the single linked list completely. So let us finish single linked list coding part, and then if time permits, I will explain how to delete or insert a node in doubly linked list, or I left it for you to understand it by yourself, and that will not be a part of exam. That is only for your knowledge. Okay, so that's it from data structure. So I'm not following any book for data structure because there is only 2 3 lectures in data structure. So what you can do, you can just follow Geeks for Geeks and try to understand the basic concept of linked list. You need to search only two things: advantage. We can search array versus linked list first of all, and read it. The basic difference between array and linked list. What is the advantage of array? What is the disadvantage of array? And the same thing for linked list. That you have to find out. This is the first thing. Second thing, you study linked list separately, insertion and deletion in linked list. That you also need to be search and try to understand. So this is the only two tasks I'm giving you from data structure. And next class I'll explain you how to write a program for all these things, insertion and deletion in single linked list. Okay, so thank you for watching this video. I'm stopping this lecture here.